Multiplying and dividing fractions. When we multiply fractions, essentially all we're doing is multiplying the numerators, a times c, and multiplying the denominators, b times d, and then we reduce if necessary. But there is an alternate approach, a preferred approach, and that's to reduce first and then multiply straight across. Let's look at these examples. 2 sevenths times 3 fifths. 2 sevenths times 3 fifths. Now, one approach is to rewrite it as one single fraction, multiplying the numerators on top, 2 times 3, and the denominators on the bottom, 7 times 5. And then multiplying what we have. 2 times 3 is 6, 7 times 5 is 35. Since no number divides into both 6 and 35 besides the 1, we are finished with this problem. Now let's look at the next example. 7 ninths times 3 fourths. This is a much better example. Now, once again, we can take 7 times 3 as our numerator and 9 times 4 as our denominator and multiply 21 over 36. Now this one will reduce. One number divides into both 21 and 36, so that number will be 3. So let's divide the numerator 21 by 3, divide the denominator 36 by 3, and we are finished. Now we're going to show you an easier way, a more preferred method. Let's take that 7 ninths times 3 fourths, and let's write it again as we have here. 7 times 3 over 9 times 4. Now before we multiply, look at this fraction. Does any part of the numerator divide or reduce with any part of the denominator? And the answer is yes. The 3 and the 9 are both divisible by 3. So let's do that. 3 divides into 3 one time, 3 divides into 9 3 times. Then we multiply. 7 times 1 is 7, 3 times 4 is 12. This is a much easier way and the preferred way. And the reason why it works is because of the way we can write it. We can write it as a single fraction. Now, you don't have to write it as a single fraction. You can look at it as it is, as the problem is written. And since we know we can write it like that, which means any part of the numerator can divide with any part of the denominator, we can do the same thing over here and just think any numerator can divide with any denominator. Any part of the numerator can reduce or simplify with any part of the denominator. You want to do that. So, avoiding this step, we could easily could have done this. 3 goes in 3 once, 3 goes into 9 3 times. What that means is we can reduce vertically or diagonally. Never ever reduce straight across. You can only multiply straight across. 7 times 1, 7. 3 times 4, 12. Same answer, same fraction. Easier process. Keep that in mind. This is actually the easiest way to do it. And with these two examples, it just goes to prove you gotta divide by 3. Either you multiply and then you divide, or you divide by 3 and then you multiply. Doesn't matter how you do it. I don't care. Nobody cares, but you're gonna find out. This is the easiest way, especially when you have big numbers roaming around. It's like this next example. 18 over 15 times 25 over 36. Let's do this one. Now, there's no way that I'm going to multiply 18 times 25 and then 15 times 36 and reduce that, because those are big numbers and I don't know if I could do them quickly. But if I reduce first, then I can do this problem really quickly. 18 and 36. Now I know what the largest number is that divides in both 18 and 36. Let's assume that you don't. Assume that I don't. Let's say that we know that 9 does. So 9 goes into 18 2 times. 9 goes into 36 4 times. Now, I easily could reduce 18 and 15 also. Nothing says I couldn't. Let's look at what we have and say that 15 and 25 reduces. And it does, because we know that 5 goes in both of those. 5 goes into 15 3 times, and 5 goes into 25 5 times. Now, it's perfectly fine to go 2 times 5 is 10, and 3 times 4 is 12, but 10 over 12 reduces. I prefer to reduce first. the 2 and the 4. That can be reduced further. 2 goes into 2 once, 2 goes into 4 twice. Now there's nothing else reduces because 1 over 3 and 1 over 2 won't reduce. 5 over 3 and 5 over 2 won't reduce. I multiply what we have left over. 1 times 5 is 5. 3 times 2 is 6. Now I could have done this problem even quicker if I recognize that 18 divides into 18 and 36. 18 goes in 18 one time, 18 goes in 36 two times. See that? So if you use the biggest, it will save you some work. Now let's do a problem that's got variables in it. X squared over y cubed times y to the 4th over x to the 5th. Now I'm going to do this the long way, and I'm going to show you how to look at it and do it. And so here we go. The long way is just to expand everything. X squared is the same as x, y cubed is the same as y, y to the 4th is the same as y, 4 y's. Next to the 5th, the same as x times x times x times x times x. All we're going to do now is cancel. Those two x's will cancel 2 of those, leaving those 3. These 3 y's will cancel those 3 y's, leaving a single y on top. We just write down what we have left over using exponents as shorthand. We have a y on top. We have x times x times x on the bottom, which is the same as x to the 3rd. Now we could have bypassed this work right here and just thought about it. These 2 x's will cancel 2 of these x's, leaving 3 x's on the bottom. These 3 y's will cancel 3 of these y's, leaving a single y on top. So if you want to do it that way, I highly recommend it. Now let's look at this example, 2/5 squared. All an exponent means is just repeated multiplication of the same base. Since the 2, let me make it a little bit bigger. Since the 2 is on the parentheses, I like to do it like this. That means I need to draw 2 sets of parentheses. What's inside the parentheses here is what goes inside both of those here. 2/5 and 2/5. And then you multiply. 2 times 2 is 4. 5 times 5 is 25. And we're done. That's all that means. Now we're getting to some more interesting questions. Division. Dividing fractions. First thing you need to worry about or know is the reciprocal. Another word for reciprocal is flip. If I take a over b and I flip it over, we get b over a. So if I were to ask you, what's the reciprocal of 2/3? You would say 3/2. If I were to ask you the reciprocal of 7, the first thing you would need to notice is that 7 is the same as 7 over 1. So the reciprocal of 7 or 7 over 1 is 1 over 7. Keep that in mind. You will need to use that. Division. Now look at this. A over b divided by c over d is equal to ad over bc. Now the way that we get that isn't the cross multiplying. It does not hold true. What we're going to do is flip over the second fraction and then multiply. So when you divide fractions, you're multiplying by the reciprocal. A over b divided by c over d becomes a over b times d over c, and then you multiply straight across. That's where that comes from. Multiplying by the reciprocal. Now this little saying is extremely handy. I highly recommend remembering it. Keep, change, flip. You keep the first fraction, you change division to multiplication, and you flip the second fraction. So let's do this example. 2/7 divided by 3/5. Watch this. Watch what we're going to do. We're going to keep the 2/7 and we're going to change division to multiplication, and we're going to flip the 3/5 over to 5/3. Now we're done with division. It's a multiplication problem. I'm looking to see if anything reduces from numerator to the denominator. Nothing does. So I'm going to multiply straight across, and I'm finished. The second example in the notes was 18 over 15 divided by 25. So let's do that one. Let me make sure that's what it was. Yep. So on this one, first thing I highly recommend, put that 25 over a 1, and then you take it from there. Keep, change, flip. Now we're seeing if anything reduces. Now a lot of people will automatically think, well, since 18 and 25 don't reduce and 1 over 15 don't reduce, it doesn't reduce. But they forget the most basic way to reduce. 18 over 15 reduces. 3 goes into 18 and 3 goes into 15. See that? Don't ever forget vertically. Most people get stuck on just looking diagonally. Never forget vertically. Then you multiply straight across. These are much smaller numbers now. 6 times 1 is 6. 5 times 25 is 125. Here's the thing about this. If I reduce first, I don't have to worry about reducing that number. If this doesn't reduce any further, then this doesn't reduce any further. Got that? All kinds of advantages to reducing first. Let's do one more example, one that has letters and numbers in it. Letters and variables. I like to say letters just so you're more comfortable with dealing with letters or variables. Once again, keep, change, flip. Now I'm going to do this a quick way, just so you'll know that it's not near as bad as it may appear. 8 and 24 reduces. 8 goes in both of them. 8 goes in 8 once. 8 goes in 24 3 times. See this x squared? It's the same as x times x. There's 2 x's. See this x cubed? It's x times x times x. There's 3 x's. These 2 x's will cancel 2 of those x's, leaving an x. And by the way, when you cancel, it doesn't mean they go away. It means that we're just reducing down to a 1. Don't ever make that mistake. Canceling just means reducing to 1. So 1 times 1 is 1, and x times 3 is 3x. And that's how you multiply and divide fractions.